All right, next up, we're going to learn how to count significant figures and identify uncertain digits in measurements, right? So when we take measurements, we don't just take measurements, we often take measurements and then use them in conjunction with other measurements, right? We multiply them, we add them, right? Depending on, what science we do. And so in order to do the math, we need to sometimes need to know how many sig figs a number has or where the uncertain digit is. And so what are sig figs? So sig figs are your significant figures, and these are our certain digits, right? The ones that we know are correct, and our uncertain digit, right? So they're all significant. So for example, when we have 21.7, we have 1, 2, 3 sig figs. And then our sig fig furthest to the right is always going to be our uncertain digit. So this 7 right here is your uncertain digit. Right, that's the one that was guesstimated. And then after that, we took the measurement of 21.68. If we think about it here, all these 3 are our certain digits. So those are significant. And then that one's our guesstimated, our uncertain digit. So that's also a sig fig. So this has 4 sig figs. And in this case, the uncertain digit is now in the 100th place, whereas before it was in the 10th place. And so you can look online of how to identify what are sig figs. I think it's easier to think about what isn't a sig figs. So we're going to do what aren't sig figs. And basically any non-zero number is a sig fig. So only zeros can be not sig figs. So let's take a look at which zeros are not sig figs. And so the first type of zeros that aren't sig figs are leading zeros. So for example, if your numerical value is 0.000045, those zeros are before our non-zeros, so they are leading zeros, and so they are not significant figures, right? In this case, we would only have 2 sig figs. And our uncertain digit would be this 5 right there. It can work for non-decimals too. It just doesn't really make sense. Like, for example, the number 45, you could write as 0045. I don't know why you would, but if you ever do, that doesn't add sig figs. You still only have 2 sig figs here. And really writing it in scientific notation helps make it a lot more sense, right? If we were to write this number in scientific notation, we would write 4.5 times 10 to the negative 5. Right, so you can see how this one does indeed only have 2 sig figs. The second type of number or zero that is not a sig fig is trailing zeros. To the left of a decimal point. And there are no sig figs after them. So for example, this number 3,000,000. These are all trailing zeros. They're to the left of the decimal point because if you think about where the decimal point is, it's right there. Right, so they are not sig figs. In this case, this number only has 1 sig fig. And the way we would write this in scientific notation is just 3 times 10 to the 6. We would not write as 3.0 or anything like that, because then that would imply that we have more sig figs than we do. There are ways to signify that zeros are sig figs. So for example, one way to do that is to, if you, for example, write the same number here, and then you underline it. If you underline it, that means that the number is a sig fig. And it's really the uncertain digit, right? Which again is a sig fig, right? So now we know the 3 is a sig fig. This underlined zero is a significant figure because it's underlined. And now all of the zeros between these two sig figs are also significant. So in this case, we would have 5 sig figs. And of course, your uncertain digit would be that underlined number. If we wanted to write that in scientific notation, we would have to identify that those are indeed significant. So you'd have to write 3.0000 times 10 to the 6, right? Those zeros, now they're to the right of the decimal point, they do become sig figs. If the zeros are to the right of the decimal point, then they are significant. So for example, 350.0, this 0 is to the right of the decimal point. So that means that it's significant. These are obviously non-zeros, so they're significant. And then this 0 is in between sig figs, so it too is significant. So you would have 4 sig figs right here. And then of course, your uncertain digit is this last number here. The best way to learn this stuff is just through practice. Let's just do a couple of examples real quick. But of course, you want to do this on your own. Watching somebody do something and you doing it yourself are two completely different things. Cool. No new notifications. Thank you. All right, let's take a look at how many sig figs each number has, right? So all of these are leading zeros, so they are not sig figs. So these two are your sig figs, and then this is your uncertain digits, right? So it's 2 sig figs, and the green number or green underline underlines the sig or the uncertain digit. Here we have non-zeros, so those are indeed sig figs. We have a 0 trapped between sig figs, that's also a sig fig. And then this 0 is to the right of the decimal point, so it is also a sig fig, right? If it wasn't a sig fig, why would you even include it, right? It'd be easier to write it without it. So all 4 of these are sig figs, and of course, the rightmost sig fig is your uncertain digit. Here we've got all non-zeros, so they're all sig figs. And of course, your rightmost sig fig is your uncertain digit. Here again, all non-zeros, even if they were 0, let's change this to 0. It's to the right of the decimal point, so they are indeed sig figs. And that's your uncertain digit right there. Here we've got a whole bunch of trailing zeros to the left of a decimal point and no underline. So that's also, so those are all not sig figs. And in this case, you only have 1 sig fig. Right? If you write the measurement out like this, what this means is that I think I have about 100,000. I might have 100,000. I might have 200,000. I might have 300,000, right? This number right here written as like this has very low precision. This is just pretty much a wild guesstimate. Over here, right, non-zero, that's obviously a sig fig. And then we've got a 0 to the right of a decimal point. So that's a sig fig. And then all of these zeros become trapped between 2 sig figs. So they are also sig figs. So in this case, we have what, 6 sig figs. And then your uncertain digit is this in the 10th spot. Oops, meant to underline that one. So again, right, non-zero number, that's a sig fig. We have a number that's a 0 that's underlined, that's a sig fig. And then these two become trapped between, so they are also sig figs. So we have 4 sig figs here, and that underlined 0 is our significant figure. Finally, there's this notation. I won't use this notation, and I don't see it used very commonly, but it is technically another way of notating it. If you have the decimal point, what you're saying is that this 0 is significant. I won't use this, but just in case you see it elsewhere, you can know what it is, right? So the 1 is significant. This 0 is significant because they included that decimal point to the right of it. And then the zeros are trapped in between, so they also become significant. So we have 5 sig figs here, with our uncertain digit being in the 1's place.